Hello everyone, I'm Frank and welcome to Frank Puzzles. In the month of November, I'm going to be trying to upload 3 videos every month. Two that are going to be of the very easy, or average difficulty level, and then one that's going to be average hard or very hard difficulty level. And this is today's easy level puzzle, I think. Um, and it's called Organic Whispers by Psy. And here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 once each in every row, every column, and 3x3 box. German whispers. Adjacent digits on a green German whisper line must differ by at least 5. So, for example, if this were a 9, this could be a 1, a 2, a 3, or a 4. Kropki dots. Digits separated by a white dot must be consecutive. So, for example, these two digits must have a difference of 1. So if it was for 2, this would have to be a 1 or a 3. Digits separated by a black dot must be in a 1 to 2 ratio. So there's only one set of that. So there's only one black Kropki dot. So say this was a 2, this would have to be a 1 or a 4 because it has to be in a 1 to 2 ratio. And not all possible dots are given, which means we are given in this information that these two digits are in a 1 to 2 ratio. These two digits are separated by 1. But you could have two digits separated by 1 somewhere else in the puzzle, and you could have two digits that are in a 1 to 2 ratio somewhere else in the puzzle. It's just that this is positive information that we're given. And those are the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, so for German whispers, first of all, there can never be a 5 on a German whisper line, uh, in a normal German whisper line. So for that case, with normal Sudoku rules, I guess. In box 5, where is the 5 going to be? It can't be in any of the lines that have a German whisper on it, so therefore this is the 5. Similarly, it can't be here then because of Sudoku rules, so the 5 has to be somewhere here. The 5 has to be somewhere here. It can't be here. I think that's all the information we're kind of given. Okay. So for German whispered lines also, I like coloring them because that gives you a sense of what I color them high and low. So that gives you a sense of what is possible. But the thing is, we don't know which one's high and which one's low, right? So we just color them two distinctly different colors. So that's pink. Whoops, that's pink. This has to be orange, and because this is orange, you can only divide it into highs and lows because if you have 1 through 4, they can only be next to a digit that's 6 through 9, and vice versa. 6 through 9 can only be next to a digit that's 1 through 4. So it's always, you have an alternating pattern on a German whisper line. So, therefore, you can go, this is pink then, this is orange, which makes that pink. This pink makes that orange, which makes these pink, which makes these 3 orange, which makes these 2 pink. Right? So this is how you go. This is how I go, shall we say, of solving German whisper line puzzles, because it makes it much easier to visualize what's going on, right? So for example, here we have 2 highs and 2 lows. We don't know which one's which, but we do know one's 2 highs and 2 lows, right? This would be 3 highs and 2 lows, right? So this could be either another low or it's a 5. Or whatever pink is. It could be high. So this would be orange. This is pink. Orange. Pink. Orange. So this is pink. This is orange. This is pink. Orange. Pink. Yeah, just continue coloring. So we can do it more easily along, yeah, that. These are orange then, and these are pink. So you get a decent sense of what things are, right? So for example, here we have 4 oranges, right? So the other one has to be pink and a 5, right? Because we know these 3 are pink. We have 4 oranges, and we know one of them, they're either high or low. Therefore, this has to be pink or 5. And this has to be orange or 5 for the same reasoning, because there's 4 pink in that one. So this is orange and 5. So we know this is a pink orange pair, this is a pink orange pair. Yeah, this is a pink or 5, this is an orange or 5. Okay, crop your dots. These are consecutive and these are consecutive. So one of them's pink and one of them's orange, right? Because we have 2 of each in there. So this is either orange or 5. We don't know. And this is either pink or 5. Oops. Pink or 5, right? This is a pair of pink and orange. This is a pair of pink and orange. We have 3 pinks here, interestingly enough. So say this was orange. That means the rest are pink. And there's a 5. Oh, you can also figure out stuff related to this, right? This sees 2. Okay, so there's has to be a 4 and a 6 in box 5, right? They can only be next to one unique number on a German whisper line. This is unique next to 2. This is 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 next to 2. So therefore, none of those can be 4 or 6. So the 4 and the 6 have to be here. Which means in this, the 1 or 9 is here. The 1 or 9 is here. The 1 or 9 is here. The 1 or 9 is here, right? So we know those are 1 or 9. So this is 2, 3, 7, 8. Right? And this is 2, 3, 7, 8. This cannot be 7. So therefore, if it's 2, it could be 1 or 4. If it's 3, it's 6. If it's 8, it's 4. Right? So this is 2, 3, or 8. Because 7 can never be in a 1-2 ratio with any digit. So this cannot be 1 or 9. This means it has one of them has to have a 3 and the other one has to have a 7, right? Because you have either 2, 3 or 3 or 4 for the low, and you have 6, 7 or 7, 8 for the high. So we know there's a 3, 7, 3 or 7 here. There's a 3 or 7 here. So this has to be okay. So these are next to 2. Right? These are next to 2, so it can't be a 4 or 6. These are next to 2, so it can't be 4 or 6. So this has to be a 2-8 pair, which means we have 4, 6, 4, 6 here, right? Hmm. So whatever these two are, it cannot be here and it cannot be here. That doesn't really help us much, though. Hmm. So this number has to be either here or here, right? Because this sees 2. These all C2, right? That sees two unique digits. This sees this sees two unique digits. This sees two unique digits. This one doesn't actually. But the problem is it's pink, right? So the pink one cannot be there. So we know this is 1, 2, 3, 7, 8, 9. This is also 1, 2, 3, 7, 8, 9. The orange has to 4, 6 has to be here. The purple 4, 6 has to be here. Right, because it can't be that one. It can't be any of these. This could be a 4 or 6. This could be 4 or 6. So let's mark the ones that we know have to be 1, 2, 3, 7, 8, 9, right? So 1, 2, 3, 7, 8, 9. Okay, so this cannot be 1 or 9 because the 1 or 9 has to be there. So that can't be 1 or 9. The orange. 2, 3, 4, 6, 7, 8. This is 1, 2, 3, 7, 8, 9. This is 1, 2, 3, 7, 8, 9. 1, 2, 3, 7, 8, 9. Again, that cannot be 1, 9. 1, 2, 3, 7, 8, 9. This is 2, 3, 4, 6, 7, 8. Hmm. Okay, what does this mean, though? Where is this orange? This orange is either here or here. That doesn't really tell us much. Okay. Okay. If this is 6, 7, and this is 8, it could be many things. That doesn't tell us very much, too, either. We know these 3 are orange. Mm, 2 and 8 have to... Sorry, 2 and 7 and 3 and 8 have to be next to each other. Which doesn't tell us much information, either. 2 and 8, 3 and 7. So therefore this cannot be 3 because it... No, 3 would have to be next to 8. This can't be 2. This is next to 2 unique ones because of those 2. So this is 1, 2, 3, 7, 8, 9. This is next to 2. It's 1, 2, 3, 7, 8, 9. This is next... this doesn't... Next to... This is 1, 2, 3, 7, 8, 9. Because it's next to 2. 7, 8, 9. This is 2 or 8. So since this is 2 or 8, this cannot be 4 or 6. Because if it's a 4, it would have to be 8, but that's 4 away. Same thing with 6. So this is 1, 2, 3, 7, 8, 9. This could be 4 or 6. Okay, this is 1, 2, 3, 7, 8, 9. What does this mean? Okay, so this cannot be 4 or 6 because the 4 or 6 for that color is there, right? So this is 1, 2, 3, 7, 8, 9. This is 1, 2, 3, 7, 8, 9. This is the 1 or 9 from the orange, so this cannot be 1 or 9. In fact, both of them are seen by, yeah. These both see this one. So because of that, this cannot be 4 or 6, right? Because 4 or 6 has to be next to a 1 or 9. So this is 1, 2, 3, 7, 8, or 9. This is also 1, 2, 3, 7, 8, or 9. Interesting. Okay. If this is 5, this has to be 4 or 6. I don't know how much that tells us. Oh. Yeah, this can't be 4, 6. Oh, wait, no, we're looking at 1, 9. Never mind. Never mind, never mind. Okay. 2, 7, or 3 and 8. Hmm. So if this is 8, this would have to be 7 and 2. Hmm. What does it mean that this could be 5? Okay, so if they're the same... Hmm. Yeah, we're gonna make, I don't know, make yellow the 5. Okay. It's symmetrical though, right? So let's say one of these was 3, right? If one of these is 3, then this becomes 8, and this would have to be 6, 7. So this would be 3, 4. This would be 2. Yeah, that seems possible. This can't be 7 anymore, right? If this is 7, what's it next to? It could only be next to a 2. Oops. So this can't be 7. Uh, so say this was 3, 8, 3, 8, 3, 8. This could still be 2, right? So it could be 3, 8, and 2. That works. Hmm. Yeah, maybe we try solving for this, huh? If this is 1, this is 2. That's 1. So this has to be 4. We have 9 and 9. This is 6. This is 3. This is 8. I mean, that all seems to work, right? So if this was 2 and 1, this would have to be obviously 4. This would be 1. This would be 6. This would be 3. So this is 8. This is 7. This would have to be 2 again. This would be 8 or 9. 2 or 3. 3 or 9. So this would be 9. I mean, it all seems valid, right? What happens if this is 6? That seems valid too. And then we would know the 6 is one of those. 6, 3. This would be 8. So this is 2 or 3. What about if this is 8? So if this is 8, this would be 4. So this would be 3. This would be 7. This would be 2. That would be 2. This would have to be 1. This would be 9. This would be 4 and 6. That would be 1 and 9. So this would have to be 8. Yeah, it all seems valid. This would be 4, so this would be 9. Yeah, doesn't tell us much. Huh. Hmm. Hmm. I feel like I'm missing something obvious here. Okay. Anyways, else can we go? What else can we go look at? Say this was 7, right? One of these is 7. If one of these is 7, then this becomes 2. So this has to be 3, 4, which means this is 6, 7. That's possible. This is 8. Hmm. Hmm. Oh, that's interesting. If this was a 6, this would have to be a 1. This would be a 4. This would have to be high though, right? So this would be 6, 8, 4. This seems possible. So it have to be 3. So this is 2 and 7. To make that 2. Yeah, this seems feasible. This would have to be 2. Oh, wait. Yeah, yeah. Okay, well, that's one thing I'm missing. This can't be a 1 or a 9, right? If this was a 1 or a 9, it would be the same as that. So this can't be a 1 or a 9 because it sees the same here, right? Interesting. So this is the orange. So, okay, where is the orange 1 or 9? It has to be here, right? These are 2, 3, 7, 8. That's a 4 or 6. So this has to be a 1 or 9. Same here. This has to be a 1 or 9 because this sees both. This sees both. This cannot be a 1 or a 9 because it's the same as that color. So, actually, no, that's this can't be a 1 or 9 because of that. So, yeah. So therefore we know that's a 1 or 9. That's a 1 or 9. So the 1 or 9 orange has to be there in that column. So that could still be 4 or 6. We don't know. So the pink 1 or 9 is here. The pink 1 or 9 is here. What? This is also pink 1 or one of these three is pink 1 or 9. So the 4 or 6, one of them has to be here. Can both of them be there? It's possible. Yeah. Possibly. So if this is 5, this would have to be 4 or 6. Which means that can't be 5. So this is 5. So that would be orange. Which doesn't tell us very much. If this is not 5, this would have to, they would both be pinks. So 5 couldn't be there, so that would have to be an orange. That would have to be an orange. No, that could still be a 5. Yeah, my brain's not working too well right now. Okay. Oh, wait. This sees 2 that are unique. Okay. This sees 2 unique digits, and neither of them could be 1 or 9. So if this was a 3 or 7, it would have to see. Say this was a 3, it would be 7 and 8, which is not possible. So this cannot be 3 or 7. This is 2 and 8. So this is 2 and 8, which means this is 3 or 7. If it's 3 or 7, that means the other one has to be 2 or 8. Right? So this cannot be the 3 or 7. So this cannot be 3 or 7. This is 2 or 8. This can't be the orange 2 or 8. This can't be the purple 2 or 8. Because they're here. So again, this sees both of these, so it has to be 2 or 8. So it cannot be 6. Therefore, we know this is low. So we know that's low. I don't know what that tells us. This is 2 and 8. This is 2 and 8. So this can't be 2 or 8. This has to be 1, 3, 7, 4, 6, or 9. Because this sees both 2 and 8s. So this cannot be 2 or 8. This is 3, 7, 4, or 6. Which means this can't be 3, 4. This cannot be 4 or 6. So since this can't be 4 or 6, this cannot be 5. So 5 is not allowed there. Same logic here. This can't be 5. Because this is 3, 4, 6, 7. This is 3, 4, 6, 7. Because it cannot be 1, 2, 8, or 9 for the purple. And it's the same color. So this can't be 4 or 6. So we have orange, orange, orange. This could be purple or yellow. This is purple or yellow, so it could be 5. Okay, so this can't be yellow, so this is purple. This can't be purple or yellow. Sorry. This is orange or yellow, but it can't be. So this is orange or yellow. So we know these are orange. So we have 4 oranges, and this has to be purple. So we have 4 purples. So this has to be orange. So orange is blue, and purple is, or pink is red. Whatever the colors are. Whatever colors you want to use, okay? We know the 4, 6 cannot be here. This has to be, so it's 3 or 4. If it's 4, it's 1 or 9. If it's 3, it could be 2 or 8 along with it. So this is also 1, 2, 3, 7, 8, 9. Since that is 1, 2, 3, 7, 8, 9, 1, 2, 3, 7, 8, 9, 1, 2, 3, 7, 8, 9. Oh, sorry. This can't be 1, 2, or 3, right? Let's use the actual one. So this is 2, which makes this 8. This is 3. This is 8. This is 2. This is 7. This has to be 2 then. So this is 2. This is 8. This cannot be 3, 7, 8, or 9. This can't be 2, 7, 8, or 9. This cannot be 2, 3, 1, or 8. Or no, 1, 2, 3, or 7. So this is 8. This is 6. So this is 1 and 1. This can't be 8. There has to be an 8 in one of these, right? If it's 7 or... this has to be 8 or 9. So this is 9. No 2, 3. No 2, 3, 4. No 9 or 7. This is 1 or 3. So this has to be 8. And since this is 8, this cannot be 4. So this is 3. This is 1. This is 7. This is 4, 9. So this has to be a 4 since that's a 1. This is 1. No 1 or 3. No 7 or 8. No 4, 6, 7, or 8. So this is 2, 3, 2, 3. So the 4 is here. This has to be a 9 because this can't be 7 anymore. No 7, 8, 9. No 7, 8, 9. So it's 1, 2, 3. This has to be 6, which forces this to be 1. No 1 here. This could be 2, 3. Can't be 2, so this is 3. This is 2. This can't be 6 anymore, so this is 8. 1, 2, 3. No 1, 2, 3. No 8. This can't be 3. This has to be 3. So this is 9. This could be 8 or 9. This can't be 3. This can't be 3. Or 4. You have 6, 7, 6, 7. This is 4 or 5. This could be 5, I guess. Right, so this is 5 and 6. This becomes 7, 8, 7, 9. This is 7 then. Wait. Does this work? Oh, yeah. This has to be 6. Okay. So this is 1, 2, 3, 4. No 2. This is 1, 2, 3, 4. Okay, so no 3. So this has to be 2 and 1. Which makes this 2, this 1, this 3, this 2, this 4, which makes that 9. So this is 7, 9. This is 8. No 7 here. So if this was 3, this would be 4. If this is 4, this can't be... This can't be 4. If this is 4, this doesn't work. This can't be... If this is... So 4 is one of those, 8's one of those, so this is a 4-8 pair, this is 5, 6, or 7, this is 5 or 7, the 6 has to be here, this can't be 6, so this can't be 7. Similar logic here, so this has to be, cannot be 6, 8, or 9, so this is 7. This can't be 7, so this can't be 6. This can't be 3, so this can't be 4. So we have 4, 8 there. This has to be 2 or 6. Right, so this is 4, 5. Which forces this to be 5. This is 4, this is 5, this is 4. We have a 3, 9 pair here, so this is 3, this is 9, so that makes that 7. This can't be 7 anymore. This is 3 and 4. This is 7 and 6. So that makes that 2 and 6. That makes that 8 and 4. We have 5 and 6. This can't be 6, so this is 6, this is 5. We have 4 and 7, so this can't be 4, so this is 4, 7, 5, 6, 7, 5, 6. We have 8 and 9 and 8 and 9 here. This is 1 and 5 and 1 and 5. Now this can't be 8, so this is 9, this is 8. This becomes 1 and 7, so this is 1 and 7, this is 3. We have, what, 4 and 5, this is only 4, this is 5. We have 3 and 6, so this is 6 and this is 3. This big 3 in the corner. This is 1 or 2. We have 1, 2, or no, can't be 2. So this is 1, this is 2, this is 5, this is 1. We have a 9, and this is a 5. And that's the solve. Sorry, it took me a little longer. My brain's a little tired right now. But I hope you enjoyed the solve, and I guess I'll see you next time on Frank Puzzles. Take care.